This is the brief on coordinate orthogonality. So, you ever wonder how we get robots to move so precisely, or how we can even begin to understand atoms? Well, a huge part of it comes down to verifying something that sounds pretty simple, that our coordinate axes meet at perfect 90-degree angles. And believe me, it's not just some abstract math drill, it's the secret sauce. First, let's touch on the math itself. The core job here is to prove that for coordinate systems like cylindrical and spherical ones, the directional axes are truly orthogonal. In plain English, it just means that when you move in one direction, say radially outward, you get absolutely zero movement in another direction, like rotation. They have to be totally independent. Second, this is where things get really practical. Robotics. Because those axes are independent, the incredibly complex math a robot needs to do gets way simpler. This is what prevents so-called parasitic movements. It means a command to simply extend an arm won't accidentally trigger a spin. You get clean, predictable motion. And finally, the same powerful idea is absolutely essential in atomic theory. The perfect orthogonality of spherical coordinates is what allows physicists to mathematically decouple an electron's motion. They can essentially separate its distance from its direction, which turns a wildly complex quantum problem into a set of simple, solvable equations. So proving these coordinates are orthogonal is precisely how we break down the world's most complex physical problems into parts we can actually solve.